This presentation covers how TDP, which is based in Silicon Valley at Palo Alto, supports deep tech, the NSF, the federal government, angel investors, other funders, researchers, company founders, policymakers, economic developers, and other stakeholders in deep tech ecosystems. The presentation will be followed by a brief Q&A session. Deep tech covers many areas including genomics, robotics, nanotech, clean tech, AI, biotech, quantum computing, and other applied areas such as contested logistics. The challenges across all of these various areas of deep tech include the need for patient capital to fund and support research and development consortia, which in turn will need to be conceived of, formed, and operationalized. As background, TDP Data Systems presented its AI and data platform as a service at the 2018 ACA Summit. TDP's promotional blurb for the summit was that by combining AI, machine learning, big data, and human intelligence, TDP was accelerating Fortune 500 and Global 2000 corporate strategy and investment decision-making, including startup acquisition and partnering. Corporate functions were analyzing and generating data-driven insights in seconds and in real time, which used to take them months or more. The message then was that TDP's approach for Global 2000 could be applied to the supply side of startups in the angel community. At the summit, TDP demonstrated that using machine learning, a startup's competitors could automatically be generated for potential investors to evaluate in real time. This could be used for many use cases, including startup benchmarking and competitive analysis to improve investment decision-making. This underscored the adage that AI would not take your job, but someone using AI will. During the same year, Stanford University had TDP present how it was accelerating innovation to researchers, technologists, and investors at Stanford's Disruptive Technology Summit. The first deep tech challenge is the increasingly hidden or inaccessible data that slows the evolutionary pace of deep tech. This is caused by an explosion of growth of data and new data silos across the growing number of deep tech topics. This causes data to be hidden or inaccessible within and across data silos. Since the 2018 ACA Summit, TDP has been using its approach to address the challenges of deep tech, which include increasingly hidden and inaccessible data that slows the evolutionary pace of deep tech, forming and maintaining deep tech consortia, needing years of research and development, requiring significant technical expertise, supported by patient capital, with the primary risk being technical risk. With this growing number of data silos, it is as if we were standing in a field with countless haystacks, each with its own potential and a unique set of needles, and those insights could help accelerate the pace of deep tech. Illuminating these needles will help address the deep tech challenge of hidden data. As such, TDP expanded its internal data beyond startups and corporations by ingesting 1,000 databases and data sets, including organizations, federal government, startups, corporates, SMEs for set-asides, nonprofits, and NGOs. Contextual, environmental, social media, topographical, socioeconomic, policy, regulations, health, community, societal resources, STEM, infrastructure, funding, and individuals. This allows for the generation of correlated, causal, and predictive relationships. TDP has developed technologies and processes to ingest data in real time. For example, TDP just ingested 70,000 research paper abstracts from a UK university in less than 30 minutes. Starting in 2022, TDP uses increased data coverage to expand its proprietary library of analytical algorithms and predictive models. This in turn was used to evaluate 200 metropolitan statistical areas to compete for the NSF's 2022 Regional Innovation Engine solicitation, which is worth almost $1 billion. TDP evaluates regional capacity to compete by specific deep tech topics and used it again for the NSF's 2024 Engine solicitation. To make sense of the explosion of data, TDP uses machine learning to make sense of the language used to describe innovation in deep tech. This is because startup founders and researchers continue to tag what they're promoting with new keywords to try to break through the marketing clutter. This is causing the language used and the underlying meaning to evolve quickly. TDP also uses machine learning to expand the number of keywords a subject matter expert may provide. For example, the Department of Energy provided TDP with 40 keywords, and TDP expanded that list to 200. This increases the potential solution space and optionality and allows TDP to restructure the databases it is working with based on the expanded keywords. Going from right to left, users of TDP's platform as a service can choose which databases to work with, select analytical and predictive algorithms to apply against the databases, and generate scorecards in real time for every row of data in the restructured data. It could be hundreds of thousands of rows. This allows the computer to assess vast amounts of data and to do so objectively, which humans cannot. The computer-generated scorecards then direct humans on where to focus next, since humans can deal with new and novel situations, which computers cannot. This allows for the efficient deployment of human analysts, which is the expensive piece of the process. And by combining computer and human intelligences, this offsets the respective biases of both, with humans in the loop. TDP's approach does not use black box generative AI. Rather, TDP retrieves data from trusted, curated databases and turns it into actionable information using traceable, auditable, and trustworthy AI. Since at the frontiers of research, emerging technologies and startups, there tends to only be partial solutions. TDP uses its system to assess, score, rank, and combine various resources in real time to create holistic solutions. TDP ecosystem maps. The Department of Energy's Berkeley National Laboratory asked TDP to present at its Next Gen AI workshop in April of 2024. TDP presented its process to generate a deep tech ecosystem map using quantum computing and AI to increase transmission efficiency and electrochemical storage for desalination plants. The first step of the process is to frame the ecosystem map by identifying the addressable pain point, underlying root causes, and the market for providing a solution. The next step is to use machine learning for keyword analysis and expansion to define the potential solution space. The third step is to run dozens of technology overlaps and crosses. This is to address the issue that in search engines you can't yield useful results with complex searches, such as combining bundle fusion and computer vision. TDP then algorithmically evaluates, scores, ranks, and benchmarks various cohorts of technology providers and other resource providers as components that can form an ecosystem map. Generating cohorts of potential providers generates optionality if the lead provider drops out, and this de-risks the process. TDP then combines the various components and graphically represents them in an ecosystem map. TDP can generate an ecosystem map in under an hour. These ecosystem maps become the roadmap for consortium formation, which is another challenge for deep tech. TDP's technologies and processes de-risk and compress deep tech decision-making by up to 80% or more. To braid and blend public funding streams to help provide patient capital for deep tech, TDP has created a rolling 24-month predictive model assessing how the federal government budget authorization and appropriations will affect available funding. To identify funding, TDP runs through its model deep tech keywords such as semiconductors, wireless, vehicle charging, or health. TDP's public funding model can be run forward and backwards in time. This is the historic view of funding for semiconductors by year and by department agency. This is a heat map of semiconductor awards for the last 10 years. This is a TDP scorecard algorithmically assessing a specific federal government funding opportunity for a semiconductor fab. TDP algorithmically assesses cohorts of potential prime contractors for specific government funding, in this case for the semiconductor award. This is a TDP scorecard algorithmically assessing a potential prime contractor for the same award. Investors and decision makers need to look at deep tech not just in the US, as the number of impact of global consortia grow. This is underscored by the recent announcement from the NSF regarding its newly formed relationship with Germany. To this end, TDP has been evaluating deep tech on a global basis, including for consortium formation. This will affect the value propositions and projected revenue streams for potential investments and commercialization strategies for deep tech. TDP's data-driven and evidence-based approach de-risks and compresses this decision-making. Please contact us at jim.beddoes@decisionplatform.io. We will now open it up to Q&A.